Hello out there, Physics 277 students and any other YouTube viewers who may be watching this video. This video is another in our series of how to use the Linux command line interface, and in this video I'm going to be discussing the information that is provided by the ls command when we ask for the ls, or the long form listing I should say, by providing the -l option to the ls command. And let me illustrate this by example. So in my current working directory here, I'm going to execute the ls command, and I'm going to give it the -l option, which produces the long form listing of files and directories that I have present in the system. And you can see I've got a number of files and directories here, and there's a lot more information that's provided. And I'm going to break down what information is provided here in these fields of information for each particular file. And you can see we have a listing of every file and every subdirectory that's present here, except for the ones that are hidden. Remember, the ones that begin with a dot in their name aren't listed, and I have to supply the -a option to see those. So let me do that. I'm going to say ls -a -l this time, and you can see I've got a listing here that includes a couple of others. In particular, I've got two directories listed here. The one that is denoted by dot, which refers to the current working directory, and the one that is denoted by dot, which refers to the parent directory. Right? If you're not familiar with the notion of the current working directory or the parent directory, go back and see my video about the Linux and Unix file system, and I'll put a link to that video near the end of this video over to the right hand side. So go back and review that if you're not familiar with that. So let's focus on the rest of this. What is this information that's provided on each line for each of these files or directories? There's a lot of information that's provided there, and I'm going to break it down field by field here and each line. So let's start with column 1 of each of these lines. What information is provided in column 1? Oh, before I do that, let me actually even go back and stop here. You'll see there's a line here after I execute that saying total 52. What is that information? That's telling you that within this file system, right, that this particular directory, there's a total of 52 blocks in the file system, and the block size may vary from machine to machine, depending on how you have the file system set up, or even within the file system on a given machine, as to how big of a block it is. But it's telling me that there are 52 blocks of information that are used to store the information that is present in this directory. Typically, we're not going to pay too much attention to that. But let's talk about on each individual line here what we actually see. So let's start with column 1 for most of these other files and directories. And you can see in column 1 there's either a D or a dash for each of these entries in the directory. And that indicates whether or not the object is either a directory, which is indicated by having a D in column 1 of this long form listing, or a dash, which indicates it's not a directory. That is, it is an ordinary file. So, in this particular case, I have 3 directories that pop up in this listing. There's my directory here, my subdirectory that I created called subdir1, right? And there's a D in column 1 for that listing. That indicates that this is a directory. Similarly here, for these 2 lines, which I'm highlighting right now, you can see that there are D's in column 1 there. That indicates for the first line, which is the dot entry, that's my present working directory, that this is indeed a directory. And dot, which is the parent directory, it also indicates that it's a directory. So you can use that information from column 1 to tell whether an object is a directory or a file. Now, for the ones that have a dash, all we know is that they're not directories. It doesn't tell us what kind of file it is. It may be a executable file, and maybe a non-executable file. That isn't provided in this long form listing. Now, let's talk about the rest of this information later, the next 9 columns. We're going to come back to that in a bit. All right. The field 2, which is this number here, 387 1112, what are those? That is what is called the number of hard links to the object, right? It indicates the number of times that the directory or the file is referred to elsewhere in the file system. We're typically not going to be terribly concerned about that. The fact that there's an 87 here is an artifact of the fact that my parent working directory here is my home directory, which has lots of subdirectories under it, and that's the reason that number is larger than it is in these other cases. But we're typically not going to be too worried about that. Now, column 4 will be the owner of the file, and it will list the username of the owner of the file. In this case, for all of these, it lists dswesty, indicating these are directories or files that belong to me, and it shows my username. Column 5 will list the group that the file or directory belongs to. What do I mean by that? Well, Linux and Unix operating systems have the ability to group users into groups, right? Now, on some systems, the system administrator, when they created your account, may have put you in a group of users that are typically called users, right? And so it may say users there. In this case, since I'm showing you this on my own personal Linux computing system, my group, right, which I belong to, is the group dswesty. It's the same as my username. I could add other people to that group if I want, but it's a group of users that belong to my group, right? Think of it as my cohort, my posse, right? At any rate, this will list what group the file belongs to, and that's going to be important because we're going to be able to set permissions so that people in my group, users in my group, can do certain things to the file. And then finally, there'll be, after that, the next, I shouldn't say finally, but the next field after that will be the size of the field, or the size of the file or the directory in bytes, right? On some systems, or maybe blocks in other systems. That may be determined by the way the file system is set up. In this particular file system, it's showing you the size of this in bytes. In this particular case, for my current working directory, it takes 4096 bytes in the current working directory. It doesn't mean all the files only use 4096 bytes there, but that particular directory, which is a list of files, only takes 4096 bytes. Here's another example. Here is, let's look at this file here, hello_world.fo8, which will probably be your first Fortran program that you ever write. In this case, there's a 93 here, indicating it took 93 bytes to store this file. On the other hand, here's the executable file that was obtained by compiling this source code file here to produce an executable file that will run, and this takes 8808 bytes in order to store. Okay, so that field basically contains information about the size of the file. Following that, there is a timestamp on the file, and what is typically displayed is the time of modification of the file, meaning that the time the file was last changed. That may be different from the time the file was created. If you create a file and you never change it, the last modification time and the creation time will be the same thing. However, if you create a file and then subsequently change it, like edit it with an editor like Emacs or VI, then the time of modification will be different from the time of creation. And here you can see this is listed for hello_world.fo8. It's August 12th, 1448, meaning at 2:48 p.m. according to the time on my computer on that day. That's when I last modified this file. Now, if the file is sufficiently old, say for example the file were 5 years old, it would not show me the hour and minute of the modification time. It would typically only show me the year and the date. So it would show me something like 2015 August 12th for something like that. Now, the last field, of course, is the name of the file or the symbol that refers to the file, and that's pretty straightforward. So let's talk about these second columns, basically 1 through 9. What information is provided there? All right. Let's look at the example here of hello_world.fo8 for this particular file. And I'll highlight that information right there in those columns. What is actually provided? Well, these are the permissions for the file. And what do I mean by permissions? Well, Linux and Unix file systems have this concept of permissions associated with them, meaning what can I do with this file, or what can people who are in my group do with this file, or what can all users on the system do with this file. And those permissions usually result or can be broken down into 3 different areas. They can be permissions about whether you can open the file, that is read it, whether you can write to the file, which means modify it, including deleting it, or execute the file for some reason. So let's look at what we see in this particular listing for hello_world.fo8. what does this mean? Well, let's focus on columns basically 2, 3, and 4 right here. There's an R, a W, and a dash. What does that mean? Well, the R in column 2 means that I, as the owner of this file, have permission to read it. It would be very uncommon for you to have a file which you don't have read permission on, right? And not having read permission would be signified by having a dash instead of an R in that column 2. So I have permission to read that file, which means I can run programs that can access that file, things like the cat command or the more command, right? The W in column 3 means that I have permission to write to the file, which means that I can open the file and modify it somehow. And that also includes the ability to delete the file. All right. The dash in column 4 here indicates that I have no ability to execute this file. It is not an executable file. Let me contrast that with this file right above it, hello_world, which is the executable file I got by compiling this Fortran code file and producing an executable file. And if I look at columns 2, 3, and 4 there, you can see in column 4 there's an X instead of a dash. That means I have execution permission for this file. I can run it like a command. I can say ./hello_world, and the file is executing, right? It's executable, right? Now for directories, let's look for example at subdir1 here. You'll see an X there. In the case of a directory, if you see an X in that column, all right, that'll indicate you have permission, or whichever group or the users in general, that indicates there's permission to basically open that directory, which means I can move into it with commands like cd. All right, so I can say cd subdir1, and that's a result of having that X appear right there. All right, let me move back up one directory level again. Okay, now what about the next 3 columns after that? Here, this would be columns 5, 6, and 7. All right, what do those pieces of information indicate? That means the fact that there's an R there, that means that any user who happens to be in my group, that is this group dswesty right over here, has permission to read that file, they have permission to write to that file, and they have permission to execute. In this case, it's a directory, so they have permission to enter that directory. All right. Well, you might think, that's probably not a good idea, right? But that doesn't necessarily mean they can do it. It means potentially they could do it. Here, the limiting factor is that the parent directory of this directory up here, let's look at this, right up here. In columns 5, 6, and 7, there are all dashes there, right? That means that any user who is in my group does not have permission to A, read, B, write, C, execute that directory, meaning they can't enter that directory, right? And since it's the parent directory of my current working directory, it means that they can't get access to these files. So it doesn't matter in some sense what the permission for any of these files is, all right, individually. The fact that the directory has excluded those users means that my files are all protected here. There's nothing anybody can do with them. And this last group here of columns 7, 8, and 9, this indicate permissions for the general set of all users on the system. The fact that there are dashes in those, in this case, means that they can't read, write, or execute this directory, that can't enter this directory. So even though down here on this file, hello_world, there's a R, a dash, and an X, meaning that if a user could access this file, they could read this file, they could execute this file. Doesn't mean they're actually going to be able to do it, because the directory that contains this file has the permissions for those things turned off. So the permissions fall into 3 sets. There are permissions that apply to you, the owner of the file, or whoever owns the file. There are permissions that apply to the group, and anyone in that group can do those things to the file if the permissions are sufficient to do that for the group. And there's a set of permissions that apply to the world in general, to all users on the system. Right? Now, just because those permissions are indicated for a given file doesn't mean users in the group or users in the world, or the set of all users, can actually do those things. They require permissions to enter the directory into which that file is contained. All right? So On your home directory, you're typically always going to want to see your home directory appear with a listing like this to indicate that you have read, write, and execute permissions. That's what columns 2, 3, and 4 here. And then columns 5 through 9 have dashes, meaning that we can only see permissions that are only people who have access to that file, or the only people who have access to that file, I should say, is the owner, and anyone else in the group or anyone else in the world has no access to that file, that directory, or any files or directories contained in it. Okay, one last thing, and this is specific to the MATLAB systems that are here on the Stony Brook campus for my Physics 277 students. When you go into your MySB files directory, your permissions in some sense aren't going to matter. And that's because in your MySB files directory, what you're actually working with is a file system from a Windows computer that is actually mounted on the Linux file system. And so it doesn't fully support the idea of permissions. Essentially, nobody other than you is going to be able to access or execute your file. All right, so you don't have to worry about that for anything that's stored in your MySB files directory or below that. All right, so these features that I've described here apply to a full-fledged Linux or Unix operating system. So with that, we'll stop. We'll conclude this particular video. If you are unfamiliar with any of the concepts such as parent working directory or current working directory, or understand absolute paths or relative paths, please go back and review my video on Linux and Unix file systems. I'll put a link to that on the right hand side here. If you like these videos, please consider subscribing. If you have questions about it, if you're one of my Physics 277 students, see me during office hours, or post a comment, and any general viewers are welcome to post comments about the videos. I'll be happy to entertain those. Otherwise, give me feedback. Let me know how you like these or not. I'm always happy to take comments of any sort that are constructive. Otherwise, I will see you here next time.